Okay, Jason notices the three lamps no longer all glow with the same brightness. Lamp A is brighter than lamp B and C. Discuss why lamp A is brighter than lamps B and C, even though they're all identical lamps. You may use calculations to justify your answer. Okay, so this one also would have been a tricky question to do because there's not a lot of calculations you can do accurately with this. But if you're assuming that they're all the same resistance, is just my redrawn version of the diagram earlier. If you assume they're all the same resistance, then this parallel section is going to be a total resistance of R over 2, because you've got twice the pathways with, so the current's going to split up, but you've got twice the pathways with, it makes it, yeah, 2 R's, you're effectively doubling the width, making it twice as easy for the current to go through. That's what I'm trying to get at. Anyway, so discussing why lamp A is brighter, because it has a lower resistance in that parallel section, it will have a lower voltage as well. So the voltage, remember, divides according to the ratio of resistance, according to the ratio of resistances. So you will have a greater proportion. What that means, you'll have a greater proportion across the higher resistance. So you've got R as your ratio to R over 2. So that means your voltage ratio will be whatever the voltage happens to be here. So if that's, let's just call that, okay, we'll call it V, just because it's easier. So the voltage here has to be the same ratio for the parallel section, the parallel section. So if it's 12 volts, as we know, you can treat this kind of like an equation, and you can say that 2V, I'll just rearrange it, 2V equals V, but 2V plus V has to equal to 12. So 3V equals 12, so V equals 4 volts. Now I've done something wrong here. No, this is still dealing with just the ratio. So 4 volts, if this was 4, this would be 2. But we know we've got 12 volt supply, so this is actually 8, and this is 4, because that adds to 12, and that only adds to 6. So you can work out from the ratio that that's 8 volts, and that's 4 volts. That could be your calculations if you like. But remember, we're assuming that the resistance is the same, which you can't actually do because they're non-ohmic conductors. So the resistance of this one will actually be higher because it's brighter and hotter, and the higher you heat something, the more the molecules vibrate and the harder it is for the electrons to pass through. So in any case, assuming they're all the same resistance, an awful assumption, but assuming that you're going to have twice the voltage across the series resistor, which means you will have twice the energy drop, because remember, voltage is joules per coulomb. This test has been really big on that concept of voltage.